Hello, I'm Hanman from Avi College of Engineering Mechanical Department. Today I'm going to give a presentation on embedded system in automobile. I will start the presentation by giving introduction to the embedded system. Then we'll see characteristics of embedded system. Then we'll compare embedded systems with personal computer. Then we'll see applications of embedded system in automobile. Then lastly, conclusion. So, what are embedded systems? Embedded systems are computer systems that are designed for specific applications. According to the definition from IEEE, an embedded computer system is a computer system that is part of a larger system and performs some of the requirements of that system. For example, a computer system used in an aircraft or rapid transit system. Embedded systems are unlike a general purpose computer system that are always dedicated for a special application, so that a developer could optimize them in order to reduce size, power, consumption, and cost. In recent years, with the development of the embedded technologies, embedded systems have been more and more widely used. Before we move further in the presentation, we'll discuss a little bit about CAN. So, what is this CAN? CAN stands for Controller Area Network. It is a hardware and software communication protocol originally developed by Robert Bosch in 1986 for in-vehicle networks in cars. Application of CAN in automobile include engine control communication, body control, and onboard diagnostics. A CAN bus enables microcontrollers in a car to talk to each other without the need of a network host. A typical automobile has dozens of microcontrollers that communicate with each other via various CAN buses. CAN buses can also be found in other embedded control applications such as factory automation, building automation, and aerospace systems. CAN buses employing twisted wire pairs were specifically designed to be robust in electromagnetically noisy environments. Characteristics of the embedded system. Sophisticated functionality. Since the embedded systems have to run complex algorithms to perform specific functions within a given time frame. Dependable. An embedded system must be reliable and maintainable. The embedded systems are always integrated into a device. The entire device could not work if the embedded system does not work or breaks down. The assembly and heat dissipation problems must also be considered. As a fixed part in a device, embedded system must be designed to avoid this problem. Reliability and maintainability are particularly important for them. Real-time operation and dedicated user interface. Most embedded systems do not use keyboard or large monitor for the user interface. Instead, they use a dedicated user interface consisting of a push button, steering wheel, etc. Users can also control the device. They cannot modify the programs. The positive side is that it is good for the security of the system. And real-time efficiency. Embedded systems generally have real-time requirements. An embedded system is usually used for controlling of procedures. Embedded systems could set a time frame. A process must be finished in this certain time frame. This is the real-time requirement. It is a very important feature in the assembly line application. Next, must finish operations by deadlines and also low manufacturing cost. Now we will compare the embedded computer systems with personal computer. We got to know that embedded systems are always designed for special equipments. So, they must be designed to be suitable for those devices. The first point is CPU. A general CPU is designed for the needs of a general purpose computer. General CPUs have very high computing speed so that they can compute a task faster or have better performances in multitasking. A general CPU structures are very similar. But in the case of an embedded systems always use CPUs that are specifically designed for embedded application in considerations of energy, size, and cost. So according to the different embedded application, the structure of the embedded CPUs should be dedicatedly designed. The next point is OS, that is operating system. It is almost impossible that a general purpose computer has no operating system. But the situation in the embedded system is quite different. We do not need operations in some particularly easy embedded system functions that can run directly on a hardware platform. It is not necessary to set an operating system on them. But in other complicated embedded systems, the support of multitask may be required, and then we need a dedicated operating system for them. So These operating systems are totally different from what we use the desktop operating systems like Windows. Next is the expensibility. Generally, an embedded computer system cannot be upgraded like a general purpose computer. We usually cannot improve its performance by extending or upgrading hardware. An embedded system is a fixed part in a device. The, the structure, installation, and even the interfaces are fixed. They are integrated in a dedicated computer system. So, an embedded system generally does not have an expansion capability on its hardware. Next is the standardization. PC is the most general purpose computer. Its mainboard, memory, power, external device interface, and even the screws that we need to assemble the chassis are fully standardized. There are 100 bands of mainboard or memories, but they all have uniform standard. But in the case of an embedded system do not have such standard like PC. Each embedded system is a function-specific design. The design and the production of its hardware and software must be in line with the application. It could be totally different from one another. So it is impossible to develop a unified standard for embedded system. In this slide, we can see that different applications of the embedded system in the automobile. We can see that the embedded systems can be used in the engine area, in the interior of the car, in the exterior of the car, in the tires also. So now I will explain in detail some of the applications of the embedded system that are more common in today's automobile. I will start with the explanation of the most common embedded system in automobile, that is airbag. We all know that the objective of the airbag, which is deployed when the vehicle suddenly deaccelerates, is to prevent the vehicle occupants from hitting any hard surfaces and reduce the forces on their heads and the upper or lower bodies. Airbags are passive safety devices that are mandatory on all vehicles sold in India. Airbags are the critical part of the supplementary restraint system in most vehicles, and airbags are typically made of nylon fabric and are hidden behind the panels at various locations in the vehicle, including the steering wheel. And depending upon the crash sensitivity, the rate at which the airbags are deployed is decided by the airbag control unit. In the event of a crash, the crash sensor, that is an accelerometer sensor, sends a signal to the airbag control unit. This control unit triggers the inflation device, which generates the nitrogen gas by igniting a mixture of sodium azide and potassium nitrate. The time between the crash detection and the complete deployment of the airbag is approximately 0.05 seconds. One thing we have to note here is that the airbag deployment speed is about 200 miles per hour, which itself can be harmful in certain areas. So, this has given rise to the adaptive airbag system that employ multiple inflators to produce either low-level or high-level deployments. These systems can adjust the airbag pressure depending upon the factors such as seat position, size of the passenger, crash severity, or seatbelt use. In 2012, Volvo became the first automotive manufacturer to introduce what is called pedestrian airbag system in its V40 model. It uses a pedestrian contact sensing system. When impact with the pedestrian is sensed, the hood opens from the back and an airbag is inflated over the windshield wiper A. Now we will see ABS, which stands for Anti-Lock Brake System. These systems play a significant role in improving the safety of modern vehicles. Anti-lock brake system prevent the wheel lock-up by modulating the braking pressure. In slippery road conditions or on smooth surfaces, a driver may hit the brake so hard that one or more wheels locks, and what happens is it begins to skid over the surface. This results in longer stopping distance or maybe a loss of stability and leads to the vehicle instability. ABS systems monitor the wheel speed in real time and regulate the brake pressure automatically in order to prevent the wheel lockup and improve the driver's control of the vehicle. They are now often paired with other systems such as electronic stability control and traction control to further increase the vehicle control and driver safety. The main components of these systems include regular brake parts, wheel speed sensors, and a hydraulic modulator operated by electronic control unit. This figure, this figure shows the architecture of the ABS system. This figure shows the schematic of the anti-lock brake system. When operating in normal condition, the outlet valve C of the hydraulic modulator is closed and the inlet valve stays open until the pressure reaches the desired value. Then both the inlet and the outlet valves remain closed to hold this pressure and provide sufficient brake torque for wheel brake cylinders. Once the control unit detects any excessive wheel slip, the corresponding outlet valve is opened to release the pressure to the accumulator and prevent the possible wheel lockout. The excess brake fluid is returned to the master cylinder through the return pump. After the wheel slip returns to normal, the valve solenoids are de-energized and the hydraulic modulator resumes the regular braking process. Another important term in the anti-lock brake system is slip ratio. Slip ratio is a means of calculating and expressing the locking status of the wheel. It is the ratio of the difference between the vehicle speed and the wheel speed to the vehicle speed. For example, when the vehicle is running normally on an ideal road surface, the slip ratio is 0. When the wheels are locked, the slip ratio is 1. During braking, as the slip ratio rises, the ABS system maintains an ideal slip ratio of 0.1 to 0.3 based on road tire friction characteristics. In this way, the vehicle maintains a maximum deacceleration without a total loss of steering capability. Now we'll see another embedded system that is most commonly used, that is electronic stability control system. It has many names such as vehicle dynamic control, dynamic stability control, electronic stability program, etc. It is one of the most significant active safety systems in modern automobiles. The main function of this system is to improve the handling performance of the vehicle and prevent possible accidents during severe driving maneuvers. Generally, these systems stabilize the vehicle by applying the necessary yaw moment and regulating the slight shift angle of the vehicle based on comparison between the vehicle state and driver's demand. Some electronic stability control systems also reduce the power from the engine during excessive steering. What happens is a vehicle may go in a direction different from one the steering wheel position indicates when the driver tries to turn very hard or turn on a slippery road. What happens in this situation? The vehicle may understeer or it may oversteer. In an oversteer situation, the vehicle turns more than the driver intended because the rear end loses traction and slides out. Understeer when the front loses traction and the vehicle turns less than the driver intended. This figure shows the architecture of a typical stability control system, incorporating three fundamental elements that are the driver, the vehicle, and the environment. In the normal control loop, the driver detects the deviation of the vehicle from the current road trajectory and corrects it through the steering system. When the electronic stability control system senses that a driver is about to lose control of the vehicle, it generates the necessary yaw moment automatically based on the difference between the driver's demand and actual vehicle state and helps to pull the vehicle back to the desired trajectory. Adaptive cruise control. Adaptive cruise control extends the existing cruise control systems to include a headway sensor that monitors the distance between the vehicle and the vehicle ahead. The system is also sometimes called active cruise control or intelligent cruise control. There are two types of headway sensors. One is the radar sensor that employs microwave signals, and another is a LiDAR sensor that employs a laser diode to produce infrared light signals. Both these types of sensors send a signal and monitor the time required for the signal to reflect off the object ahead. When these systems determine that there is a need to slow the vehicle, they may use engine, transmission, or brakes to decrease the vehicle's speed and maintain a safe following distance. Many systems limit the maximum deceleration to no more than 3 meters per second square. These systems usually have user interface, typically both visual and audible indications that are provided to the driver depending on the severity of the situation. Adaptive cruise control systems are evolving rapidly and are currently available on many mid to high-end passenger cars as well as many heavy-duty commercial trucks. This figure shows the principle of operation of the adaptive cruise control. What it describes is that when there is no object ahead of the host vehicle, the vehicle tries to move at a constant speed. When the sensor in the host vehicle detects any object ahead, what happens is it continuously measures the distance between the host vehicle and the target vehicle and tries to maintain a constant following interval. That is, it tries to maintain a safe distance from the target vehicle. The embedded systems which we have seen till now are like an add-on to a traditional vehicle. But there is a trend in the automotive industry towards eliminating mechanical and hydraulic control systems and replacing them with electronic controls. Many traditional and mechanical components can be eliminated, such as shafts, pumps, hoses, fluids, etc., which reduces the weight of the vehicle and improve efficiency. Electronic controls can also improve the safety by facilitating more automated control functions like stability control. They also enhance the flexibility of the automotive system, making it easier to modify or upgrade vehicles. Electronic controls improve handling, enable better fuel efficiency, and exhibit response times in emergency situations. Such systems are called drive-by-wire. This is already been implemented in aerospace industry, where the traditional linkage control system are substituted with the drive-by-wire system. Drive-by-wire consists of three main systems. One is the steer-by-wire, throttle-by-wire, brake-by-wire. The first one is steer-by-wire. Steer-by-wire systems do not have direct mechanical connection between the steering wheel and the wheels of the vehicle. Instead, turning the steering wheel sends instructions to an electronic control unit. The control unit actuates an electric motor that controls the steering angle of the wheel. Steer-by-wire systems have some advantages, like there is more space available in the engine compartment. Interior styling is more easier and more versatile. This system can be modeled and installed as a modular system, simplifies design and lowers manufacturing cost. One such system conceptualization is given in this figure. Steering wheel position and the angle is measured by the hand wheel sensor, which is linked to the electronic control module through an electronic control unit linkage, which generates the torque. Environmental sensors analyze environmental factors like yaw, rollover position, and positions using cameras, which are translated into engine control module. Using all these inputs, tires are actuated using steering sensors, and angle of the steering rod is controlled and thus monitored by the ECM. The second one is throttle by wire. Throttle by wire is an automotive technology that is widely used on vehicles today. It replaces the traditional throttle linkage with an accelerator pedal, position sensor, and an electronically operated throttle. It provides several advantages over mechanical systems, such as eliminates the binding problem in mechanical linkages, preventing throttle from sticking, allows automated control of the throttle that helps to reduce the emissions and improve fuel economy. This system can also be modeled and installed as a modular system. The figure shows one of the throttle by wire conceptualization system. The accelerator pedal sensor senses the position of the accelerator pedal. This information is conveyed to the ECM as a change in the electrical resistance. The ECM actuates a servo motor which actuates the butterfly valve in the throttle assembly. The position of the throttle is continuously monitored and the information is conveyed to the ECM using a feedback unit. Thus, the throttle is controlled using an ECM. Brake-by-wire is an automotive technology that completely eliminates traditional mechanical and hydraulic components and replaces them with electronic sensors and actuators to control the brakes in vehicles. Some of the advantages of brake-by-wire systems are reacts more quickly, resulting in shorter stopping distance and time, and loss of mechanical system results in noiseless operation and elimination of vibration, reduces the overall weight of the overall system, thus improving fuel efficiency. We have to note here that brake-by-wire systems are still under development and cannot be found on passenger cars that are currently in the market. One of the several concepts for a brake-by-wire system is illustrated in the figure. This system consists of a rheostat that senses the position of the brake pedal. This signal is interpreted by a brake computer which generates signals to operate a servo pump. The pump pressurizes the secondary circuit and the brake fluid pushes against the slave piston that activates the brake. The pressure is monitored and signal is sent back to the brake computer, which applies a mechanical force to the pedal and feedback to the driver. We have to note that complexity of the drive-by-wire system is a concern to many automotive customers who worry about the failure of the software and possible electronic malfunctions in sensors, resulting in car accidents and passenger injury. As I have said in the starting of the explanation of the drive-by-wire system, these drive-by-wire systems have been used by commercial aircraft for many years and have an excellent safety record. Ultimately, the enhanced safety features and the other benefits of automated electronic controls are expected to outweigh the concerns about the complexity and reliability of these controls, and drive-by-wire systems will be widely used in the automotive designs. We will now see automatic rain sensing wipers embedded system. We all know it's one of the most emerging embedded system in recent automobile. We all know a windshield wiper is a device used to remove rain from the windscreen. Almost all motor vehicles, including trains, aircraft and watercraft, are equipped with such wipers, which are usually an essential requirement. A wiper generally consists of an arm pivoting at one end and with a long rubber blade attached to the other. The blade is swung back and forth over the glass, pushing water from its surface. The speed is normally adjustable with several continuous speeds and often one or more intermittent settings. Most automobiles use two synchronized radial type arms. It takes a lot of force to accelerate the wiper blades back and forth across the windshield so quickly. In order to generate this type of force, a worm gear is used on the output of a small electric motor. So why we have to go for an automatic wiper system? In the present automobile, the number of facilities is much higher. The driver has to concentrate on road while driving, and with increased traffic, things might get frustrating. The features in the car like GPRS to trace the route, music system, air conditioning system may drive away the attention of the driver. Thus an effort is made to reduce the effort put by the driver in controlling the speed of the wiper and put more concentration on his driving. Since the system is put already in higher end cars and has been successful in working, an effort has been made to reduce the cost of the system so that this system can be used in a more economic cars and also a common man can enjoy the benefits of it. This figure shows the block diagram of a wiper arranging circuit system. Here the battery supplies the power to the sensor as well as the rain operated motor. Wiper motor is automatically on during the time of rainfall. The sensor is fixed in the vehicle glass. The conductive touch sensor might be used. It senses the rainfall and gives control signal to the control unit. Then the control unit activates the wiper motor automatically. So then the blades remove the rain droplets from the windscreen. The next embedded system is head-up displays. Head-up displays were designed originally to present at the usual viewpoints of the pilot the main sensor data during aircraft mission. Because of placing instrument information in the forward field of view enhances pilot's ability to utilize both instrument and environmental information simultaneously. The first civilian motor vehicle that had a monochrome head-up display that was released in 1988 by General Motors as a technological improvement of head-down display interface, which is more commonly used in the automotive industry. The head-up display reduces the number and duration of driver's sight definition from the road by projecting the required information directly onto the driver's line of vision. A car head-up display system is formed by three main parts. The first is the combiner, the surface on which the image is projected. The second is the projector, which generates the image and directs it towards the combiner. And the last one is the computing unit, which processes data from different sources and handles the projection. The advantages of using head-up displays are: head-up display will replace the indicator cluster in the dashboard on a common car, also known as head-down display. A head-up display is a device that can help to avoid several factors that cause accidents on the road. Those factors are human error, vehicle error, accidents itself, which cannot be avoided. To upgrade the efficiency and the safety, a head-up display system must provide drivers with large amounts of information from many categories. Head-up display allows taking advantage of advances in the technology and the communication process between driver and the car. Using the head-up display causes less mental stress for the driver than the head-on display. As head-on displays are integrated into vehicles' control dashboard, by using head-up display, the frequency and the duration of the glances towards the displays are reduced by presenting information directly on the windshield in the driver's field of vision. As we have seen in this presentation, more and more equipment in automotive are changing from mechanical system to electronic system. The electronics revolution has influenced almost every aspect of automotive design, including the powertrain, fuel combustion, crash protection, and the creation of comfortable cabin and nearly wireless environment. The development of embedded system greatly facilitates the comfort of people's life, changes our view of things, and has a significant impact on society. On the other hand, even though embedded system technologies are becoming more and more mature, currently there are still many challenges in technique and will be more with the ever-growing speed and reliability demand from the market. And these are the references.